Alternate light sources or forensic light sources can be a fantastic way for us to be able to detect more evidence. They're a non-invasive and non-destructive technique that can help us to search for evidence that's not immediately visible under white illumination. So the reason that we can see different colours and different evidence using white illumination is because white light is made up of all of the different wavelengths of light. So everything all the way from violet all the way through to red light, all combine together to make white light. Now, different surfaces will absorb and reflect different parts of this spectrum, and that's what allows us to see colour. It's for that reason that something like blood spatter on a white wall would look so obvious, because the wall would be reflecting all of that light back to us, and the blood would absorb quite a lot of it, and that's what would make the blood look dark. Now, we can use forensic light sources, whether that is a handheld torch style light like the Crime Light 82 Pro, or an integrated system like the Crime Light Auto that combines illumination, filtration and cameras. We can use different wavelengths of light to view different evidence types and hopefully make that evidence a little bit clearer. So there are three main techniques that we can use for this. So the simplest of those techniques is probably oblique illumination. So this involves lighting our evidence from a low oblique angle along the surface. So this is really, really effective for 3D evidence types. So anything that's impression-like in its appearance. So whether that's deposited into or on top of a surface. We can use a light source like the 82L Pro to achieve oblique illumination. If we illuminate from above, if our evidence is 3D in nature, often what can happen is that we actually drown out and minimize a lot of that detail. Whereas if we bring our light low to the surface and light along that surface, anything that's 3D in nature is going to start generating areas of light and shadow, and that is going to show much more detail in that surface. So whether that's something like a finger mark impression, a footwear impression, or even areas on a wall in which evidence has been concealed and it's being plastered over, we can use oblique lighting to view those differences in the surface and make them much more clear. Another technique that we can use alternate light sources for is contrast examination. So this is exploiting those differences in absorption and reflection of different evidence and surface types to enhance the contrast of what we can see visibly. So in general, the important thing to think about when we're trying to achieve contrast examination is the fact that we are trying to increase the contrast. And what we need to think about to do that is a colour wheel. So to put things in the simplest terms possible, similar colours will lighten itself, and an opposite colour will darken the opposite colour. So if we were to think about the most simple example being ninhydrin on something like a dollar bill, so a green background, if we were to use green light on that surface, that green background will reflect all of that light and it will seem to lighten as we perceive it. Whereas ninhydrin develops to be a much darker purple colour, which is opposite or complementary to green. This means that when we use a green light to illuminate a fingerprint that's been treated with ninhydrin, the fingerprint will darken. So what we've achieved there is an increase in the contrast of what we're looking at. Now that's key for fingerprint photography, but where this can also come into its own in terms of searching for evidence and actually being able to detect a little bit more evidence is this technique can be incredibly useful for blood searching. So blood in appearance is quite dark, so it's a dark red-brown colour. Now actually, blood has its greatest absorbance at around 412 to 420 nanometers. So that's actually in the violet region. So one of the most effective ways to search for blood staining can actually be to use a violet light, and we can enhance that searching capability even more by using a 415 bandpass filter to just view that area of the violet spectrum and see those differences in absorption and reflection. Now, easily the most broadly used application of crime lights or forensic light sources in general is fluorescence examination. Now, fluorescence can be incredibly useful in the search for evidence because by using fluorescence, sometimes we're able to see evidence that we actually can't see at all visibly using white light. Fluorescence is a property of a surface that means that it will absorb light of one wavelength and then re-emit this light shifted towards the longer end of the spectrum, so shifted more towards the red end of the spectrum. Now, in order for us to be able to see this fluorescent reaction, we need to use a filter to block out the high intensity illumination. So at Foster and Freeman, we use LED-based light sources to stimulate that fluorescent reaction from the evidence that we're searching for. Now, the LED light sources that we use, especially when we're using something like the Crime Light 82 Pro, they're incredibly high intensity and bright. Now, the fluorescence that happens due to these light sources is much lower in intensity. And so we need to use a filter to block out the high intensity light and allow us to see those fluorescent emissions. Now, that's what we're really interested in, is those fluorescent emissions. There's a couple of different types of filters that we can use. So we can either use a long pass filter. So this is the general type of filter that we use for fluorescence. So generally what we want to do is just block out all of the light that we're using to illuminate and allow all of the longer wavelengths to pass through. That is exactly what a long pass filter will do. It will allow all of the longer wavelengths of light to pass through it, and hopefully that means that we'll be able to see fluorescent emissions coming from the evidence. But sometimes we don't have very good contrast due to perhaps weakly fluorescent evidence or maybe a fluorescent background that's interfering. And in cases like that, we can try using a bandpass filter to enhance the contrast of what we're looking at and hopefully mean that we can see our evidence much more clearly on the surface. The Crime Light 82 Pros come alongside the Crime Light Pro Vision goggles. These are a bit different to the style of goggles that we used to sell here at Foster and Freeman because they start off with a UV blocking base. So the base of the goggle is UV safe and will block out any UV light from entering the eye. Now, when we do fluorescence, what's really important is matching up that filter with the light source that we're using. So because each light source will have a different peak wavelength and a different emission wavelength, we need to match up our filter with our light source. So there's a couple of different ways that we can do this. I think that the easiest way to do this is by looking at the colour on the goggle. So all of our goggle filters are labelled with a coloured label that will match up with the labelling on the crime light. So we can either simply look at that colour or look at the goggle prompt that is on the light source in order to show us which goggle or filter we should be pairing with each light source. The filters that we supply with the Crime Light Pro Vision goggles are actually magnetic onto the front. So these filters are interchangeable. So we have one base goggle and the magnetic filters can be interchanged onto the front of the goggle depending on which light source is being used. So what we will do is take a look at some different fluorescent evidence types using the Crime Light 82 Pros to see what evidence we can find. So this surface is a pair of women's underwear, And actually on this surface, visibly, there's not really anything of interest. We can see one small area of staining, but what we can do is use a blue light source to see if there is any additional staining also visible. So as I turn on the blue 82 Pro, what we can start to see is, yes, this main area of staining in the middle just here. But what's important to note is that it's not just body fluids that we may be looking for when we're using fluorescence. So yes, most body fluids, as you can see here and also here to this smaller area of saliva staining over here, most body fluids do emit some sort of fluorescence. Some are more fluorescent than others, but fluorescence can be a fantastic tool to search for body fluids. But as we can see on this surface, body fluids are not the only thing that will emit fluorescence, and they're not the only evidence type that we might find. So across this surface, we can see that there are a range of fibres that have been left behind. So most of these, when illuminated with a blue light, are fluorescing an orange colour, but there are a couple which are fluorescing and behaving slightly differently. Now, the behaviour and fluorescence of fibres can vary hugely depending on their composition. They could fluoresce all the way across the spectrum under different wavelengths, purely due to the chemical composition and the treatment of that fibre. And so if we're searching for different fibre types, one of the reasons that it's really important to have a range of different light sources is that we don't know where that particular fibre is going to emit the best fluorescence. And so having a range of light sources can be incredibly helpful for this. Easily, the most common wavelengths used to search for fluorescence are UV and blue. Now, generally, these two wavelengths are incredibly successful. However, if I am turning on a UV light in order to try and search for the accelerant that has been deposited on this surface, you can see that there is just an overwhelming amount of fluorescence being emitted by the surface itself. We can't really see the area of interest across this surface because the fluorescence from the optical brighteners in the t-shirt itself are emitting just so much fluorescence that it's potentially overwhelming any signal from our ignitable liquid on this surface. So in this case, rather than just using UV or white light, I'm actually going to use a green light on this surface. And straight away, when we turn on the green light, we're able to see these two areas of fluorescence. These two areas can then be targeted for further testing. So we've used a crime light to search across the surface and narrow down the areas where there could be traces of ignitable liquid on this surface. So all we're trying to do when we're using crime lights is speed up that searching process, make that searching process just a little bit more streamlined and a little bit faster.